Magnetic momentum. We will complete this and then have questions. Magnetic moment. Story done. What is magnetic moment formula? M equals to I into A bar, and one more formula M equals to M into 2L bar or L bar. So 2L bar direction is always from south to north. Here also area vector direction always you have to consider. In the direction of the current you have to curl your fingers, and the thumb will gives you area vector direction. Area vector direction given by whom? Given by the thumb. Given by the thumb. So this thing is done. Do you have a question? How to calculate area vector first? Any idea? How to calculate? This is area vector or scalar? It's a vector. Calculate for this area vector first. X, Y, Z. That is how I think we know, right? Now 30 can I take? Happy with 37? Find the area vector of this object. Find A bar. Whatever. Generally, mechanics. It is mechanics. What he has to do is correct. I have to give the direction of the current. But here in magnetism, I have to give the direction of the current. In mechanics or in heat, not required. Okay. Happy? Find area vector. Area vector options I want A bar equals to some nonsense I cap plus some nonsense J cap like that. Not direction. Direction, okay, correct. Now what is the direction? Along Z axis. Along Z axis. Absolutely wrong. It is not under one axis. So that's why you have to write this. Happy with the point what I said. For example, if I give an object like this, then current in this direction. If I ask area vector, what do you tell? You have to curl your fingers and done. Only in one direction it is easy. But here it won't be in one direction. It won't be in one direction. It is having some inclined path. So A bar will get in two directions. Inclined. And so what is the two directions? Starter. How? Whenever if I ask whatever the object it might be, area vector, what you have to do, see, A bar equals to A B bar cross B C bar. A B bar cross B C bar. Next consecutive set. A B cross B C. If current direction is there, no, then definitely you have to write A B bar cross B C bar only. You have to write. Understood? You will curl the fingers. So how do you do? First in the direction of the current. Yes or no? So now A B bar cross B C bar only. No, we will get the thumb direction. That only I have. A B bar cross B C bar. For example, in mechanics, if they didn't give current direction, then what you can write? You can write anything. What is that? You can write A B bar cross B C bar, or you can write if direction of the current is not there. In that case, I am doing. If direction of the current is there, then definitely you have to write this. If direction of the current is not there in mechanics, if they ask, for example, then what you have to do? See, I can write CB bar cross BA bar. Correct or not? Yes, correct. CB bar cross BA bar. That is also correct. Next, AD bar cross DC bar. That is also correct. All possible cases you can write if it is mechanics, if direction of the current is not there. Consecutive sides, that is important. AB if you write, BC you have to write. Or if CB if you write, BA you have to write. If AD if you write, DC you have to write. If CD if you write, DA you have to write. Try to remember that point for area vector in mechanics. Absolutely correct. Consecutive sides cross product. Now here what we have to do? A bar which is equals to, if you do, I will explain the concept. This is basic. A bar equals to AB bar cross BC bar. How to calculate AB bar? AB bar is only along x-axis or y-axis or z-axis. No, it is in the plane, right? You have to resolve into components. So A cos 37 is along x-axis and A sin 37 is along y-axis. According to me, y I have written here. My question might be, you want, you can change. Happy with this XYZ or can I change? I can take, not a problem. So now what I can write? AB bar I can write as A cos 37, 3, 4, 5, 4, 5, 5. Yes or no? Understanding or not? It's not a problem. No, not understanding. Happy or not? Now, so it is A cos 37, 3, 4, 5, 4 by 5. So it is 4A by 5 I cap. Next, plus 3A by 5 J cap. Positive? Yes. According to me, y axis, so according to me, J cap. Next, BC bar. BC bar. This is B and this is also be a rectangle according to me. Okay? That is in this direction. 3D you have to see, don't see like that. This part where it is, here. That's no. This part from here it is there, you have to see here. I can't draw now, so that's why I have drawn like this. So this part where it is in this direction, so how much is that? B? K. BC upwards. Okay, so upwards Z according to me, so K. Do cross product of this, that will be the area vector for this object. That is the story how to calculate area vector. Please try to remember in heat also chances will be there. Wherever area is a vector, everywhere we have to apply this concept. Whether it is flux, whether it is magnetic moment, whether it is heat, everywhere this concept I have written. You have to learn. So A bar which is equals to I can write as now, do cross product, you will get the answer, yes or no? So cross product I cap, J cap, I think you know that was. So 4A by 5, 3A by 5 and 0 and 0, 0 B. So I cap how much? So 3AB by 5, yes or no? 3AB by 5. And next, this is 0, J cap, minus J cap, 4AB by 5. And that is 0, K cap, 0. So this will be A bar. Along x-axis and negative y-axis. Okay, it's not in one direction. Always it won't be in one direction. Not done this part from lectures. Magnetic moment. Previous part are lectures. Next, magnetic moment. Calculate magnetic moment now for this one. Take this part. X, Y, and Z. Now in this question, I place area vector here, and the current assume 2 amperes is going, and assume radius 1 meter. Assume it is circular ring. Assume this is ring, right? Don't be confused. In that ring, how much current is flowing? 2 amperes. Radius is 1 meter. Find the magnetic moment. Understood the question first. Find the magnetic moment. Two direction with direction, not MRIs. 2 pi. 2 pi correct first. I will check. How it is first? Like this. For this will be in this direction, XZ plane. If it is XZ plane, so J. So magnetic moment formula I into pi r square. So I is 2 pi r square 1 square 1, so 2 pi J s. Is it difficult? Yeah, this is one of the confused. What is the net magnetic moment? Standard questions, not Western time. So what you have to answer, yes or no? Okay. So divide into two parts. Better. Divide into two parts. So if I divide this part, see, this is a part, and then this will be a part. And now calculate. So whenever if you see this type of shapes in two planes, divide into two parts. Calculate. Side 1 meter. If I didn't, you take 1 meter. No nonsense. Okay. So this part and then this part. First calculate magnetic moment of this part, assume it as M1 bar, and cancel magnetic moment of this part, write M2 bar, and see the directions 10 M bar. Happy with the point what I said? You can ask, sir, here current only not there, no, what nonsense you are talking. Yes or no? Here current only not there, no, so how we can divide into two parts? Listen for the story. See, here current is coming in this direction, assume. See this part. If you want to close this part, current should come in this direction. Yes or no? To close this part, current should come in this direction. Both are cancelled, current 0. Yes or no? So if you want to divide this into two parts, definitely this conductor should be there, but current should be 0. So here, current direction should be this one. Here, current direction should be this one. See, both are opposite with the same magnitude cancelled. So net current in this part will be 0. So that's why I didn't draw that line. You have to think and you have to draw that line. Right? MR? MR or MR and 2 separately? MR how much? IJ kappa. IK kappa. Oh, I correct that. No? So I'm thinking I cap, K cap, what nonsense. IK kappa plus I. Is that correct? Area vector, oh, side I gave 1. Yes. Side I gave 1. So now this part, how it is? Like this. Okay. So current in which direction it is there? So if it is like this, current is going in this direction. Okay. So current is going in this direction. So J current. Right. So here current is going in this direction, coming out. So plus K. Happy with that? So this will be M1. Yes, M1, and this will be M. Don't worry about the shapes. Try to understand the concept whether we can close the things or not. If you close, you can close the things easily and you can calculate. Next, magnetic moment of a revolving electron. Magnetic moment of a revolving electron. Very important for competitive exams. If paper is little difficult, chances will be there from that part. While it was here calculating moment of inertia, angular momentum, everything we have to understand. Okay. Now, slowly consider an electron revolving in a circular orbit of radius r. Okay. So electron is revolving also with a constant speed v. Find the magnetic moment if I ask. Now start. Assume that is a question first. Electron revolving around a circular orbit of radius r with a speed v. Find the magnetic moment. First question. Find m. Okay. So next question. Find angular momentum. Third question. What is the ratio of magnetic moment to angular momentum? Three questions, standard formulas, try to calculate what is magnetic moment, what is angular momentum, what is the ratio of magnetic moment to the angular momentum. Magnetic moment formula IA E. Okay, let's see. I don't know. I didn't bifurcate the final equation except this. I know only this Q by 2A. Apart from that, nothing. Okay, we calculate. So what is I? Electron is revolving in this direction. So what is magnetic moment direction? Outwards, no? Absolutely wrong. Inward is correct. Yes. Everyone of them is outward is correct. Your friends are outward is wrong. Electron is revolving in this direction. Current will be opposite to the direction. Yes or no? So current always opposite to the direction of the motion of the electron. So magnetic moment direction is inward magnetic moment direction. So what is I? Q by T into A, yes or no? So what is the time period of one revolution? How much? It is 2 pi by omega, you can write. Yes or no? So I m, which is equals to omega q by 2 pi into pi r square. Smaller I have written there. So small r square, 1 r should be there. Okay. Omega, in terms of omega, I have written. So it is in terms of b equals to r omega. Omega is v by r. So it will be vq by 2 pi. How much? Instead of omega, I can write as v by r. So v divided by r into pi r square. So r will be cancelled. Same is vq pi also cancelled. No? Is that okay? So 1 pi cancelled, 1 r cancelled. So vqr divided by 2. So magnetic moment. This is also correct. Who said wrong? It depends on the options. Okay. So omega q by 2 pi into pi r square. Here also pi will be cancelled. Omega q r square by 2 in terms of angular. This is in terms of linear. Next, what do you mean by this angular momentum? Angular momentum. What is angular momentum? What is the relation between these two? What do you mean by angular momentum? Direction. General formula for angular momentum again. L equals to mvr. Angular momentum formula mvr. M into r bar cross v bar. In terms of cross products, m into r bar cross v bar is nothing but angular momentum. R bar cross v bar. Do the r bar cross v bar? R bar cross v bar. Particle is moving with what speed? V in this direction. R bar is radius. Outward. Angular momentum direction. Yes or no? R bar cross v bar. V bar upward. So angular momentum direction will be outward. Happy with that? angular momentum direction will be outward. So how much is that? MBR. MBR. Now, wherever it might be, circular motion topic is there, more will come into consideration. That rest will come. So what he said? Formula: angular momentum which is equals to nh by 2 pi. Yes or no? Remember this course model, second question. So angular momentum I can write as nh divided by 2 pi. So what we want now? Angular momentum which is equals to nh by 2 pi, right? So now here n is how much? VQR divided by 2. Substitute, what is it? M by L if I do. So what is M? VQR divided by 2 and into L. L is how much? NH by 2 pi. Reverse. It is 2 pi divided by N into H. So it is 2 pi divided by H. Cancel the things. 2 cancel. Yes or no? And VQR into pi divided by H. VQR into pi divided by M into H, which is M by L. Now still some stories are there. Okay, we can answer this one also. So what are those stories? Angular momentum I can write as MBR. So if I write in terms of that, that also will be cancelled. Yes or no? Try to check that. So what is M? That is VQR by 2. What is angular momentum? It is NH by 2 pi. One more way of writing angular momentum. With respect to this, I want to know. So angular momentum, another formula. Can I write it as I omega? Yes or no? In terms of this, I am trying to write. That is also okay. But still one more form. Now I omega, what is momentum inertia of this? Can I write a mass square? If electron is there, mass also will be there, no? Yes or no? This is a particle from the center. We are seeing what is the distance r. So I can write it as m square. I can write. Yes. Angular momentum formula I can write as m square into omega. Smaller or capital? Smaller. Right there. Yes. So after writing that, now divide this one and that one. What will be? One r will be cancelled. Yes or no? V also will be cancelled. What I said q by 2m we will get. When you have to apply this one, sir, when you have to apply that one, sir. This one, if any both postulates are there, principal quantum number n equals to 1, find the angular momentum or find the ratio, then you have to apply this. So, for example, if that nonsense is not there, then direct I can write as what? M by L, which is equals to how much? What is M? VQR by 2. And what is L? M r square omega. So, M r square omega I can write as again V equals to R omega. Omega is what? V divided by R. 1 R will be cancelled here, 1 R here, 1 V here. So finally, how much we got? Q divided by 2. Happy with the point? So magnetic moment divided by angular momentum. Formula is Q by 2m for competitive exams. That is very important formula. And with respect to these, if questions are there, we can do. Don't worry about that. So now, can I write in terms of vectors minus? Why minus came? No, both are opposite in the direction. Story okay. Try to write fast. Do this question. Do the question, you can understand. Concept also, I think, understood. R bar cross V bar. Both are opposite in the direction. Just I divided there. How to calculate momentum inertia, that you have to understand. See, do this. Consider a solid sphere. Consider a solid sphere. Consider a solid sphere. Okay. Placed in the magnetic field B. Placed in the magnetic field B. Assume it is rotating with an angular velocity omega. Happy with the point? In this region, inward magnetic field is there. What is that? Solid sphere I consider. With respect to this axis, it is rotating with an angular velocity omega. Find magnetic moment, find the angular momentum, and find the ratio of those two. Find the magnetic moment, find angular momentum, and the ratio of those two. What is moment of inertia of solid sphere? Remember? Moment of inertia of solid sphere. Moment of inertia of solid sphere. I, which is equals to, I think, my section students, I said something to remember. 1, 2, 3, 4, 5. 2 by 5. Something is not there. I think I said solid SOLID 1, 2, 3, 4, 5 denominator. If it is hollow, 2 by 3. Sea level process. Okay. Moment of inertia for the solid sphere is 2 by 5 mr square. By 5 mr square. Yes. 2 by 5 mr square. And start. What is magnetic moment? M equals to IA. Yes or no? Right? Sir, here charges only not there. What nonsense you are talking? One more point. Yes or no? Magnetic field is here, omega is here, then there is current. If current is 0, magnetic moment is 0. Yes or no? So now here what I am doing is small change. On the solid sphere, I am placing some charges. Happy with that? Yes or no? And this solid sphere, I am rotating like this. Charges also will rotate or not? The charges will rotate, current will come or not? Yes. Happy with the point? Is that okay? So I place the charges on the solid sphere and I am trying to rotate like this. If I try to rotate, what will happen? Charges also will rotate. The charges will rotate, current will be there. Yeah. So what is the direction of the current now in this direction? So this will be what? Magnetic moment direction. So don't change, right? Because positive charges. Right? So it will be I into E. Area, you know, you can substitute. What is angular momentum? I omega. What is I? 2 by 5 mr square into omega. Area, how much is that? Sphere, I said 4 by r square. Can I write? Yes or no? So current, it depends on the charge. Assume it as I only, or else if Q charge is there, I can write it as Q by T some nonsense again. Yes or no? So magnetic moment, which is equals to Q divided by T into area. So what is T again? For one complete rotation, again you can write it as 2 pi into omega. Right? So I think solid sphere, if you do, area will be 4 pi r square only. If I do for non-conducting ring, that concept will be different. Understood this point? So I consider a solid sphere and it's trying to rotate. If it rotates, what will happen? Definitely current will come. Definitely magnetic moment. Q by how much? T. T is nothing but 2 pi by omega into area. Same points. I am not changing the points. I change the points from here. No shape change. What I can do? They are circular motion. Here also circular, but you have to see a sphere. Complete sphere is rotating. If complete sphere is rotating, you have to take the area of the sphere. A magnetic moment direction. In which direction? This is R, S or no, and V in this direction. So V bar cross, sorry, R bar cross V bar. Both are in the same direction, so minus 1. Do one more. Don't see like that. Consider non-conducting ring, charges, and it is rotating. Non-conducting ring. Why non-conducting ring, sir? Why not conducting ring? Why not conducting ring? Why only non-conducting ring? If it is conducting ring, what will happen? If I place a charge, it will conduct. It won't be there. I want the charge to be stayed at that position where I kept. In a sense, you have to take a non-conducting ring only. Here also types of spheres, I think we studied, if you remember. I didn't tell you this class. Types of spheres, conducting spheres, non-conducting spheres. Two types of spheres will be there. What type of sphere I can study here? Non-conducting sphere. If it is conducting sphere, wherever the charge if I press, that won't be there. That will be conducting. So in these topics, definitely you have to consider non-conducting things only, not conducting things. Remember. Now, assume radius is r and it is rotating with an angular velocity omega. Find angular momentum, find magnetic moment, and find the ratio. Fast. If you do this, I will change the model. Understood the point? How to write angular momentum and how to write m, and you have to divide. That's it. Nothing more. Find. Same, m is same, I think. Yes or no? Q omega by 2 pi, but instead of area, you have to write pi r square. Apart from that, everything same. Angular momentum, assume it is moving in this direction or in this direction, either. Assume in this direction, so r bar cross v bar. Again, that is also out. If that is out, now what is angular momentum? Now, what is the moment of inertia of the ring? Moment of inertia of the ring, m r square only, no? Very good. Please try to revise first year syllabus also. Angular momentum, I omega. What is moment of inertia of ring? M_r square. If I give this non-conducting disk, moment of inertia, m_r square by 2. It is solid sphere, 2 by 5. Hollow sphere, 2 by 3. Solid cylinder, again m_r square by 2. Hollow cylinder, m_r square. If I have like this, you can do, or else no. So angular momentum m_r square omega, divide this 2. Again, I think you will get q by 2m only for this. For this. Why? Because this is also in the circular shape. So same answer will be. This is not in the circle shape, we are considering a complete sphere, so answer will be different. Study, happy? Remember this, after 10-15 minutes, again we will come back to the same objects, but we will calculate their time period of revolution. After that, again we will come back to the same concept. Next concept is about torque. Next is about torque. What do you mean by torque? 11th concept again, torque, rotational effect of force, yes or no? Rotational effect of force we call as torque. Calculate, find the torque of this. Can I give one question? 11th mechanics. This division. Remember, forget. Very good. This is the hinge point which is fixed. Try to recall the concepts. Hinge point, fixed point. Okay. So I applied a force in this direction F, and I applied a force in this direction F, and assume length of the rod is L. Find the torque of the object if I ask. But before that, find the net force. And second one, whether torque will be developed or not. Try to recall the concepts. If you want, I will do. If you know this, then direct the formula I can write. What is that? According to magnetism, torque formula will be NIAB. Sin theta. That okay. So try to understand about the torque, then directly I can write the formula and I will balance something. We will go for direct moving coil galvanometer. I'll come back. Net force is 0. F in the direction, F in this direction. Net force is 0 only, no? If net force is 0, here torque also will be torque 0. When torque will be 0? Now, what is the difference between above example and below example? Perpendicular force. So, if I apply with F in this direction, net force 0, but any rotational things are there? No, so then torque will be 0. In the sense, forces if you apply along the axis, then torque will be 0. Along the axis. Now this force, see, axis in this direction, but this force axis in this direction. So axes are not same. If axes are not same, definitely torque will be generated. If axis is same, torque won't be generated. That is the story. Now write the torque. What is torque formula? Just now I said R bar cross F bar. Yes or no? If you don't know it, torque formula is tau bar, which is equals to what? R bar cross F bar. So what is the length? Assume at the midpoint against the hinge point. Now what is the direction? Very important one, just basic I consider. In previous questions, we have some springs arrangement and find the torque they will ask. If I read translations, those things will be there. Okay. If you remember this, those things you can try. Now tell me R bar plus F bar direction here. See R bar cross F bar. Inward torque is there or not? R bar cross F bar, torque is inward. And here again R bar cross F bar, again torque is inward. So both torques should be added. So tau equals to tau 1 plus tau 2. Happy with this? Yes or no? So from the hinge point, inside. So both are inwards. So we have to add. What is that formula? R bar cross F bar. Both are perpendicular. So it will be L by 2 into F plus L by 2 into F. How much? L by 2 F plus L by 2 F. LF. So what is net torque direction? Inwards. So this will be the way to calculate torque, whatever the chapter it might be. Try to remember. I want that construction working and all. Please try to read. So any book and try to read. Now, what is the use of moving coil galvanometer? What is the use of moving coil galvanometer? Heard about it or first time you are hearing? First time. Moving the coil galvanometer. Okay. So it is used to measure the small amount of currents. Basic. It is used to measure small amount of current. Small amount of current. If you give more amount of current, it will go. Sensitivity is to more further. Okay. Two types of sensitivities we have to discuss. That we will discuss later. So what will happen in moving coil galvanometer? I think you have seen voltmeters and ammeters in the labs. If you give current, they will deflect. If you won't give, they will deflect back. Moving coil galvanometer is also same. So what is that? One pointer will be there, one scale will be there. If you give something, it will rotate. How it will rotate? Torque will be double. That's it. That's all. How it will rotate? Torque will be double. For example, cancel any string. Assume here the string is. I rotated. What happened? Torque is developed or not? It rotated or not? If we remove, again it will come back to its original position or not? Again there also, if you give current, deflected. If you remove current, yes or no? So what is this? Restoring torque. So how much torque will be developed? That is equals to restoring torque. How do you want this torque? NIAB? I have to do that. If you want to improve, or else try to say, I'll give a question only. Instead of proving that, solve this. Just basic you have to revise that now, not board level class, no. What will happen? Torque will be developed or not? No, very good. Second example, those who said no. Torque will be developed or not? Torque in the sense what? Rotational effect, yes or no? Torque will be developed or not? In the two examples, in which case torque will be developed, in which case torque won't be developed. In this case, torque developed. In this case, torque won't be developed. Yes or no? Why? Then if there is magnetic field and area vector both are in the same direction, torque won't be developed. In a sense, by having this one. Now tell me. Forces, yes, you have to see the forces, right? See this conductor. What is this? Remember forward. What is this? L bar cross V bar. If L bar cross V bar force is above, L bar cross V bar force below, L bar cross V bar force, L bar cross V bar force. Along the same axis or along different axes? Same axis. If along same axis, torque won't be developed. Just go as it. Here, why I place it like this? It's making some angle. So it is making some angle, force here in this direction, force here in this direction along the same axis. This is in this axis, and this force will be in this axis. That's all. So if axis is different, then definitely rotational will be there or not? Torque will be there or not? In this case, torque possibility is there. In this case, torque possibility won't be there. Happy with that, right? Torque possibility is there. Like this I placed. Here force, not along the same axis. So it will rotate. See the top view and write the same concept. You will get that form. See the top view? If you see the top view, what you are seeing? Only this conductor you are seeing. Yes or no? Initially like this it is there. Draw the top view. Now due to those two forces, what happened? It rotated. Initially like this, due to those two forces, what happened? Rotated. Means point. What is the point? So now this distance and this distance is equally divided or not? So force in which direction? In this direction, in this direction. See, same. What is the tap direction? R bar cross F bar, R bar cross F bar. Both are inward. If both are inward, both we have to add. Done. So add. Understood these two lines first. First this one making some angle. See. Not making any angle. So if here one force is acting, here one force is acting. So try to equate that and add those two. Finally, you will get it as NIAB sin theta also. Perpendicular things, no. Maximum torque in the sense sin theta won't be there, or else sin theta will be there. Try to write this formula for torque under this concept. A is area, right? Because here A is there and B is also there. If you do properly, you will get AB. AB is nothing but area. B is magnetic field and sin. Another formula for this, try to write the torque formulas with respect to that. We'll solve some questions. Another formula, magnetic moment formula. Magnetic moment formula, M equals to IA. If n number of turns are there in the sense, can I write NIA? So instead of NIA, can I write magnetic moment MB sin theta? So tau bar, which is equals to M bar cross B bar. Very important formula again. One more formula for that, which is M bar cross B bar. Make a question about that. Consider a ring. Consider a ring. Ring or anything you can make. Don't worry about that. Ring. Inward magnetic field everywhere. About this axis is trying to rotate in this direction. About this axis, it is trying to rotate in this direction, and assume the charges I placed on the ring, non-conducting ring. Charges I placed. Okay, it is rotating in this direction. Then what will happen? Or else direct current can I take better? Why? Because again you will ask, sir, charges are not rotating, so current is not there. That is also a point. Assume current is flowing. Okay, it will change. So assume current is flowing in this direction. About this axis, it is trying to rotate. Now find the time period of rotation. Just I gave little rotational left. Try to understand. Just I gave some little rotation and I left. What will happen? It will oscillate or not? Yes or no? Definitely yes. Why? Initially, magnetic moment direction and magnetic field direction both are in the same direction. So sin 0, 0, so torque is 0. Initially. Little I rotated. Angle downward, downward. If angle downward, what will happen? Restoring torque will be downward, downward. These are not like dipoles, what we calculate. If you rotate it and if you leave, what will happen? It will oscillate there. Angle we can calculate there or not. Same. Just little I rotated like this and I left. What will happen? Energy loss will be there, so again it will come to rest. If energy loss is not there, then we can assume continuously it is rotating. Find the time period of oscillation. Understand the point. If you understand the point, then you can calculate others. Simple. Simple story. What is time period formula? Lorentz oscillations. I think in electrostatics also we discussed. Not new point, I think. Time period, how to calculate? Tell me the steps first. Leave this nonsense question. How to calculate time period? In linear, how to calculate, and in angular, how to calculate. In linear, whatever the things it might be, first you have to calculate the net force. After calculating net force, you have to resolve that net force in terms of F equals to minus kx and D equals to 2 pi square root of m by k. In charges, if you move a charge and if you leave there, what will happen? It will oscillate. It will oscillate in the sense, what to calculate? Net force you have to calculate at that point. That net force you have to resolve in such a way that it should come in the form of F equals to minus kx. Why F equals to minus kx? If this condition is there, then we can call that oscillation is simple harmonic motion, or else no. Condition from forgot 11, very good. If you forgot 11 in electrostatics, I think in my sections I did this. In my CD districts. If charge, if you move and if you leave, what will happen? It will oscillate. If it oscillates, what will happen? Simple harmonic motion or oscillatory motion? It depends on what? It depends on this condition. If this condition is there, satisfied, then we can call SHM, or else no. Here also same. So now here angular loss are there. In angular terms, how we can write? I'll tell you. This one in angular terms, how we can write? Force, angular terms, start. Linear displacement in angular terms, angular displacement. Constant is constant only, what nonsense. So time period T equals to 2 pi square root of mass in angular terms, moment of inertia divided by Q. Yes or no? Linearly we call it as mass, in angular terms we call it as mass or moment of inertia. Moment of inertia, rotational effect of mass, moment of inertia, rotational effect of force, rotational effect of linear displacement, angular displacement. Right to remember. So now it will rotate, what will happen? It will oscillate. And now write the torque. Torque should be equals to minus k times of theta. How I can write what is torque formula? mb sin theta. So tau, what is m? Magnetic moment. Magnetic moment of a ring. How much? In the previous, I think questions we calculated. Direct IA gave, no, what nonsense. Don't see the previous one also. Direct IA. Number of turns not there. Current is I. Area, assume radius is r. Pi r square. Yes or no? Yes or no? Yes, sir. Don't tell for my sake. Understood these points or not? Yes. Recall the things you know. Not telling you don't know, but might be forward. Tell your subconscious mind to call it back. Okay. So bring it back. So try to recall. So I pi r square. What is magnetic field? B sin theta. What I rotated, that angle is very small. If angle is very small, sine is approximately equals to theta. Done. So this is in the form of this nonsense or not? So tau, which is equals to k times of theta. So this is k. What is moment of inertia of ring? mr square. So t, which is equals to 2 pi square root of m r square divided by I pi r square into b. Done. Whatever the object it might be, try to remember how to calculate the time period. So first you have to calculate the torque. Not only here, whether it is in oscillations or electrostatics, concept is same. Concept is same. Don't read only this chapter. Try to see the concept. Whatever the chapter it might be, the concept will be same. You have to apply the same concept. This is about torque. Next, moving coil galvanometer. Formulas. Anyone tell me the formula for basic formula for moving coil galvanometer? Basic principle of moving coil galvanometer. Current is directly proportional to the deflections. Remember the formulas. Current is directly proportional to what? Deflections. And another formula, if you remove this constant, I equals to K times of tan theta. Very important formula. Current and theta in terms of tan theta relation. I equals to some constant. K is constant, it depends on the material what we are using in the galvanometer into tan theta. Next. Torque, applied torque and restoring torque will be same. Applied and restoring torque will be same. Applied torque formula NIAB. Applied torque in the sense how much current we are sending. So how much current we will send, that much rotation will be there, that much torque will be developed. So I can write it as NIAB, which is equals to restoring torque, depends on how much angle it rotated. How much angle it rotated. You can write it as phi, or here I have written it as theta. So write theta into some constant. Phi also you can write, but here I have written theta, so I wrote theta. Right? So now, this is the formula. Something they ask, something you can calculate. Now, next point, sensitivity, very important. Sensitivity. Two types of sensitivities. One is current sensitivity, and the second one is voltage sensitivity. Formulas are important. Problems will come. Current sensitivity and voltage sensitivity. What is meant by current sensitivity? Number of deflections per unit current. Voltage sensitivity, number of deflections per unit voltage. Current sensitivity, number of deflections per unit current. Number of deflections per unit voltage. Calculate how much? I think theta by I is easy. See, theta by I, NAB by C. So, theta by I is nothing but NAB divided by C. Now, current sensitivity depends on, questions will come, theory questions. Theory questions in the sense, in the need theory questions. So, current sensitivity depends on number of turns, area, magnetic field. If number of turns increases, what will happen to current sensitivity? Increases. Why? Directly proportional or not? So if area changes, what will happen to current sensitivity? If magnetic field changes, how to calculate all those things. Now, voltage sensitivity, tell me how much you have to calculate. NAB divided by, so theta by B equals to NAB divided by C. How we got? B equals to IR. I already we know from here. Substitute. So B, which is equals to I, is nothing but C theta divided by NAB into R. Just I substituted I value from this. C theta by NAB. So what we want? Theta by B we want. Now we know only current and deflections relation. How we can calculate B and deflections? So I will substitute from this. So now what we want? Theta divided by B we want. So remaining term set that side, it is NAB divided by CR, where R is resistance. That is voltage sensitivity. Please try to remember the things. Next, conversions. Very important. Try to remember these formulas. Next concept. Last, after moving coil galvanometer, it is conversions of moving coil galvanometer into ammeter and as well as voltmeter. In moving coil galvanometer, after what we discussed, formulas are important. So that's why I have written only formulas. Apart from the formulas, no stories will be there. Now try to understand. Moving coil galvanometer conversion. Conversion of moving coil galvanometer into, first what you want? Ammeter. My first doubt. Ammeter already there now, why to convert again? Yes or no? Ammeter already there now in the lab. Then why again you have to take ammeter and why you have to connect a wire over there and why you have to convert? In practicals also, I think this, frankly speaking, I do lab. I'm very weak. So conversion of MCG into ammeter. Ammeter directly there now, why nonsense in the sense. In ammeters, resistances will be more. In ammeter, resistance will be more. How much if you decrease? Something will be there. Compared to MCG. In MCG, resistance we can decrease up to minimum extent. Up to minimum extent we can decrease, but here we can't decrease. Say, right? Do you have a question? And say resistance are okay connected to an ammeter, connected to a battery of potential V, and if an ammeter is there, what will happen? Resistance will be there or not? Yes or no? Resistance of ammeter I should be as RA. Now my question is, find the percentage error in calculation. Find the percentage error in calculation by using this, by using ammeter or without using ammeter. With using ammeter, without using. Whatever the percentage error actually, two concepts should be there or not in the reading. And in those two, I want percentage error. Just starting first step, step one. How much reading should come actually? V by R. Ammeter what it will do? Current only no. So actually how much current should come? V by R should come. This is what? Real reading. Real reading should be V by R. That's done. Next, measured reading. This is real reading. I have Canada real. Now measured reading, in the sense ammeter we have to place or not? Now tell me, resistance of ammeter is there or not? Now tell me how much current it will measure. V by R plus RA. V by R plus RA. Now percentage error of these two. What you have to write? What do you mean by percentage error? What do you mean by percentage error? From I think 11th first chapter we are discussing about this percentage errors. Yes or no? Still clarity is covered. I real minus I measured by I real into 100. Percentage error. In 11th what we studied about percentage error. Change of any physical quantity divided by original. Yes or no? That only I have written. Calculate. How much? How much real V by R minus V by R plus RA divided by again how much? V by R into 100. V what? So can I take R into R plus A LCM? R will go to numerator. One R will be cancelled, and here R plus RA minus R. One R cancelled. So it will be how much? RA divided by R plus RA into 100. This is the percentage error. Yes or no? Try to understand. If they ask about errors, so this is the way we can calculate. Now come back to the conversions. Why we have to convert ammeter, galvanometer into ammeter? To reduce that error. To reduce that error. How we can reduce that error? To reduce the resistance in the ammeter. So how we can reduce resistance in the ammeter? By converting. Yes or no? You can ask, sir, in ammeter only we will reduce the resistance, or how much we can reduce? How much we can reduce? That we call as an ideal ammeter. What is the resistance of ideal ammeter? Resistance of ideal ammeter 0. Resistance of ideal voltmeter infinity. So convert step. How we can convert? Ammeter always in the circuits connected in series or parallel. Series. So now, for example, consider a resistor. Some current is coming through this, and you have to calculate the current across this path. What we have to do? You have to connect direct galvanometer here, sir. Yes or no? If you want to connect, if you want to calculate the current, what we are doing, ammeter we are connecting here. So in that path, how much current is flowing? We will get. Now remove the galvanometer, sir. Place galvanometer here. Reading won't come. It will damage. First point in galvanometer, what I said. It will measure a small amount of current. For example, 1 ampere is current coming here. Current. So 1 ampere it will measure. No. Small currents only it will measure. In the sense, what you have to do? You have to connect a shunt resistance. What is the shunt resistance? Small amount of resistance connected in parallel. So shunt has S. And this is the thing that we have to do. So this as a whole we call as an ammeter, not only this one. This galvanometer and this resistor which is connected in parallel. This complete arrangement we call as ammeter. Complete arrangement we call as an ammeter. So if I current is coming here, what will happen? That I will be divided into two parts, Ig, I minus Ig. Yes or no? Now the potential across these two will be same or different? Parallel, no? Potential will be same. Potential across galvanometer equals to potential across the shunt resistance. So I can write it as Ig into G, which is equals to I minus Ig into S. What is I? That is the main current. So if you know all the remaining things, we can calculate easily. Try to remember the story. Okay? No need to buy hard. Try to remember parallelly potential same. So you can equate. So with this you can calculate I or Ig, whatever it might be. Question will be like this. See? Start. The current which can measure by the galvanometer is the current which can be measured by the galvanometer. Don't need to write that. You can write this one also. Okay. How much you can measure is assume 0.1 amperes. Question, try to understand the statements. That is important. Current what it can measure is 0.1 amperes. With that galvanometer, I want to measure the maximum current of 10 amperes. With that galvanometer, we have to measure the maximum current of 10 amperes. Okay? And the galvanometer resistance is 1 ohms. Find the shunt resistance that should be connected in it. Simple, but try to understand the statement. Which one is Ig, which one is I? Here I gave. In exam, no one will give. So that you have to understand. Which one is smaller? That will be Ig always. So bigger one, this much capacity should be there for that galvanometer. That much capacity should come in the sense how much shunt resistance should be connected. Same nonsense, you can substitute. But try to understand the sentence, statements. That is important. Answer? No? 1.9. 1 by 99. 979. The 9 or 99. It's running. S equals to 1 by 90. Less or more? Less only, no? So what I said about shunt resistance, less resistance or more resistance? Less. More resistance I said. Less resistance only. So less. Correct. Next, conversion of galvanometer into voltmeter. What you have to do? Why not voltmeter we can use? Why we have to convert? Why we have to convert? See again, do a question. Cancel resistance 5 connected to your battery. 2 14, 5, 2, 14. How voltmeter should be connected in the circuit? Always in parallel. So the resistance will be there or not? Resistance will be there. Assume it as 1000 ohms. Find the percentage error. Across what? 2 ohms only, no? Here 2 ohms if I place voltmeter. Here also where I am calculating voltage, that especially I have to tell. No. Here I place voltmeter across 2. Here also we have to calculate the potential difference across what? Across 2 only. But find the potential difference of these two measurements. Like previous question. Understand the question or any doubts in the question? Find the percentage error or just error across this and across this after connecting voltmeter. I think clear now. Without connecting voltmeter, what is the potential difference across two ohms resistor? After connecting voltmeter, what will be the potential difference that what voltmeter is measuring? Now I want the percentage error between them. Current electricity, how much you remember, we'll see now. Done? If done, I will go for concept. Okay, do that later, see the concept. How galvanometer converted to voltmeter? For example, a resistor is there. Listen. A resistor is there of assume R ohms. Across this, I have to calculate the potential difference. Happy with that? Across this, I have to calculate the potential difference. Assume current flowing in it is I. So, what nonsense, direct connect galvanometer, done no, by wasting time. It will work or it will go. It will go. Why? So, this is also having some resistance. So, with that current you will divide, more amount of current will go, it will damage. Now, what you have to do? You have to connect a resistor in series with the galvanometer that should have a high resistance. Here, R is what here? External resistance. Now, as a whole, this combination we call as voltmeter. Happy with that? So, where R dash is the high resistance, R dash and G in series, that we call as a voltmeter. Now, what to do? Potential difference across this you have to calculate. Potential difference across this and potential difference across this both will be same. So calculate the potential difference across the galvanometer. That will give you potential difference across R. How much? V, which is equals to I into R. How much current will go here? IG. So I can write it as IG into how much resistance? R dash plus G. G is the resistance in the galvanometer. That is V. And this V is nothing but the potential difference across here, where we have to measure. That's all. Take a question, statement very possible. The galvanometer, it can measure current of 0.1 amperes. And to convert that galvanometer into a capacity to measure 10 volts. That's all. That galvanometer, we have to convert to have the capacity of measuring how much? 10 volts potential. Okay, and the resistance of that is 2 ohms. Find the resistance should be connected in series. Anything they can miss, I miss this. Simple, yes or no? So substitute all the things. Anything they will miss and they'll ask, try to concentrate. Thank you.